Hello students, welcome to India on Educational. Namaste parents and educators. In today's video, we are going to discuss about atom. Alright, in previous video also we had discussed some of the important points related to atom, which were the relative size of nucleus and relatives with respect to relative size of its atom. Alright, so if you see about the relative ratio, so it we had deduced it is 10 to the power 5 times, radius of atom is 10 to the power 5 times larger with respect to radius of nucleus of a particular atom. Alright, let us check about the value of radius of nucleus. Radius of nucleus, it comes in order of fermimeter, 10 power minus 15 meter. Alright, and radius of atom, it comes in order of angstrom, which is 10 to the power minus 10 meter. So it is very obvious, if you take the ratio of radius of nucleus to radius of atom, it will come as 1 is to 10 to the power 5. Alright, okay. So we had discussed about this and about the atomic particles, about the extranuclear particle which is there, present there inside the atoms. All of them has been discussed in the previous video. Today we are going to discuss about mass and charge information about the subatomic particles. So let's get started. So here I have mentioned subatomic particles, electron, proton and neutron. Electron has 9.109 into 10 power minus 31 kg mass. You can also take it as 9.1 into 10 power minus 31 kg and do your calculation. Alright. For proton, the value is 1.673 into 10 power minus 27 kg. For neutron, it is 1.675, almost the third digit which comes after the decimal place, it is almost 5. Alright, 1.675 into 10 power minus 27 kg. Alright, so if you check about the mass of proton and mass of neutron is little bit slightly more with respect to mass of proton. So you can say, if you compare proton and neutron is slightly heavier with respect to proton. Alright, neutron is slightly heavier with respect to proton. But during calculation, almost we take it as equal value and we solve our question. Alright, for that reason I have mentioned it here. But in actual reality, neutron is slightly heavier with respect to proton. Alright. And proton and neutron altogether, if you see them, see the value here, it is 10 power minus 27 kg and it is 10 power minus 31 kg, right? So it is very little with respect to these two values. All right. For this reason, this is the actual reason why we take mass of atom as total mass, which we can accumulate from mass of neutron and mass of proton, because mass of electron is actually very lighter. It is very lighter with respect to mass of proton and mass of neutron. So mass of electron can be neglected during our calculation. All right. Charge, if you come to see about the charge, electron has minus 1.6 into 10 power minus 19 coulomb. Proton has 1.6 plus 1.6 into 10 power minus 19 coulomb. Magnitude is same. Electron has same amount of negative charge. Proton has exactly same magnitude of positive charge. Neutron is neutral in nature. Alright. And the unit which I have taken here is SI unit for mass and SI unit for charge, which is coulomb, and SI unit for mass is kg. Alright. Now the point here is relative charge. So if you want to write about the relative charge, so what you need to do is, if you see the value of charge, two values have same magnitude, but it is a negative, right? It is negative charge, it is positive charge, right? So if you divide this value with same value, 1.6 into 10 power minus 19, if you divide all three of them with the same value, you will get -1 here, 1.6 into 10 power minus 19 divided by 1.6 into 10 power minus 19. For electron, it is negative charge. Alright. So, these two will cancel out. -1 here, you will get +1, and 0 upon something, 0 divided by something, it will be 0. Alright. So this is the relative charge. For this reason, generally we take it as if you have 2 electrons, then -2 charge we take, and if you have, let us suppose, +4 protons somewhere in a particular question, we take it as +4 charge. All right. This is the relative charge which we take there. All right. Now let's move on to the next slide, which tells about mass of proton or neutron. Mass of proton or neutron, they are very heavier with respect to mass of electron. If you come to know about the value mass of electron upon mass of proton, 9.1 into 9.109 into 10 power minus 31 kg minus 31 upon 1.67, let us suppose we take it as 3 into 10 power minus 27. Kg will cancel out each other. Alright. And all in almost value, you will find it as 1 upon 1837 times. Alright. So it gives us clear information about this idea. Mass of proton is more than 1800 times heavier with respect to mass of electron. At the same time, I will also focus on one thing. Mass of proton itself is a very little value, right? 10 power minus 27 kg. It is very little value if you compare it with respect to 1 gram, 2 gram or something like that. All right. 10 to the power minus 27 kg. All right. It is very little amount, right? So with respect to proton, electron is almost 1837 times lighter. For that reason, it is already a small value, and with respect to this small value, it is much smaller. Electron's mass is much smaller. For this reason, we can neglect mass of electron, and for now you can say that mass of atom mainly comprises of mass of proton and mass of neutron. Mass of electron will be neglected. All right. With such important concepts and with such clarity, we will come with next video. Thank you so much.